Those perfectly round holes showing up in your deck, eaves, or fence posts aren't random. They're the beginning of a nesting system that expands silently every year until the wood underneath is compromised. The bees doing it are carpenter bees, and unlike most pest problems, this one gets structurally worse the longer you wait. Carpenter bees are large, solitary bees, roughly 3/4 to 1 inch long, that are frequently mistaken for bumblebees. The key visual difference is the abdomen. Bumblebees have a fuzzy banded abdomen. Carpenter bees have a shiny, mostly hairless black one. If you see a large bee that appears to have a polished rear end, it's a carpenter bee. The males are the ones you typically see hovering aggressively around eaves and deck railings. They're territorial and intimidating looking, but completely harmless. They have no stinger. The females are the ones doing the actual damage. They have a stinger, but rarely use it unless physically handled. Here's what's happening inside your wood. The female drills a perfectly round entrance hole, right around 1/2 inch in diameter, then tunnels perpendicular to the grain for a short distance before turning 90 degrees to tunnel along the grain. A single new tunnel runs 6 to 10 inches. An older reused tunnel can run several feet and branch into multiple chambers. Inside each chamber, she deposits a ball of pollen and nectar, lays an egg on it, and seals it off. Larvae develop inside, feeding on the provisions, and new adults emerge in late summer. Those new adults don't go far. They overwinter in the same tunnels. In spring, they emerge, mate, and the females either return to the same tunnel and extend it further, or drill adjacent to it. This is how a small problem in year 1 becomes a network of voids honeycombing through your structural wood by year 5. The frass you see, the yellowish, coarse sawdust piled below an entrance hole, is the excavated wood material pushed out during drilling. Fresh frass is a reliable indicator of active, current-season boring. The yellowish staining on the wood surface below holes comes from bee excrement. What makes this particularly damaging over time is the combination of structural void creation and moisture intrusion. Open tunnels absorb water, which accelerates wood rot and decay in exactly the areas that have already been weakened by boring. Woodpeckers compound the problem further. They locate larvae by sound, then peck large irregular holes to reach them, turning a 1/2 inch entrance into a ragged opening several inches across. Single-season damage from a light infestation is mostly cosmetic. The structural risk comes from years of unchecked reuse expansion. Sagging deck boards, weakened railings, rotting fascia, compromised posts. The time to act is before that accumulation occurs. Step 1. Inspection. Finding every active hole. Effective treatment requires knowing the full extent of the infestation before touching a single product. Missed holes mean missed nests, and missed nests mean the problem continues regardless of how thoroughly you treat everything else. Walk the entire structure systematically: eaves, fascia, soffits, deck railings, posts, fence boards, barn beams, and any other exposed unpainted wood. Look for the characteristic 1/2 inch round entrance holes. Take a flashlight to shaded areas under overhangs where holes are easy to miss. Mark every hole you find. Signs that a hole is currently active: fresh frass below the entrance, bees entering or exiting, or audible chewing if you put your ear close to the wood. Older, inactive holes will have no frass accumulation and no bee activity. Carpenter bees strongly prefer unpainted, weathered softwoods. Pine, cedar, and redwood are the most targeted. They avoid painted surfaces because the dried finish makes the wood harder to penetrate and less detectable by scent. If your structure has a mix of painted and bare wood, the bare sections are where you'll find the activity concentrated. Do not seal any holes before completing treatment. Sealing first is one of the most common mistakes in carpenter bee control, and it creates a worse outcome than doing nothing. Trapped bees chew new exit holes through undamaged wood, expanding the damage rather than stopping it. Step 2. Treating the nest interior. Once all active holes are identified and marked, the next step is delivering an insecticide directly into the gallery, the tunnel and chamber system inside the wood. Surface sprays applied to the entrance hole. Don't penetrate far enough into the gallery to reach larvae and eggs deeper inside. You need the treatment to reach the full extent of the tunnel. The most effective modern product for this is Fuse Foam, an expanding foam insecticide that contains 2 active ingredients, fipronil and imidacloprid. It comes in a pressurized can with a flexible straw that can be inserted deep into the tunnel and bent to follow corners. When dispensed, the foam expands at a ratio of roughly 30:1, filling the entire gallery, the main tunnel, the branches, the egg chambers, and contacting everything inside, adult bees, larvae, and eggs. Both active ingredients in fuse foam are non-repellent. Bees that contact treated foam don't detect the chemical and move away. They continue behaving normally until the insecticide takes effect. This is critical for gallery treatments because a repellent product can cause bees to avoid the treated section and chew new chambers beyond it, reducing efficacy. Insert the flexible straw as deeply as possible into each hole before dispensing. A 1 to 2 second application is typically sufficient. The foam expands significantly after dispensing and will fill more space than it initially appears to. Leave the holes open after treatment. Returning foragers will contact the treated foam as they re-enter, and any larvae or pupae deeper in the gallery will be reached as the foam expands into those chambers. For light infestations or situations where foam products aren't available, insecticide dust, deltamethrin powder, delta dust, or carbaryl applied into the gallery with a hand duster is also effective. Dust works by coating the interior surfaces, and bees pick it up on their bodies as they move through, distributing it through the gallery. Leave holes open for at least 24 to 48 hours after dusting, so returning adults contact the treated interior before sealing. Inspect treated holes after 3 to 5 days. If you see continued bee activity, frass accumulation, or bees entering and exiting, retreat before moving to the sealing step. Step 3. Sealing the holes. Once activity has stopped in a treated hole, seal it permanently. The sealing step serves two purposes. It physically prevents reuse of the gallery, and it removes the olfactory cue that draws new bees to previously used nesting sites. Old galleries retain pheromone scent that signals to new females in spring that the location is established and suitable for nesting. A sealed, painted-over hole removes that signal. The most durable sealing method uses stainless steel mesh plugs, a product called BB Pro 30, which are small, thimble-shaped screens pressed into the entrance hole. These are chew-proof. Carpenter bees and woodpeckers cannot penetrate stainless steel mesh. Press the plug flush into the hole, then apply wood putty or filler over it to create a smooth surface. Once the filler dries, sand it level with the surrounding wood. For holes without mesh plugs available, wooden dowels cut to fit and glued in place, followed by wood filler, achieve a similar result. The key in either case is finishing with filler painting over the repair. An unpainted patch of bare wood filler is still detectable by foraging females and slightly more attractive than fully painted wood. Seal every hole, including old, inactive ones. Any open hole, regardless of whether it's currently active, can be scented and recolonized. Step 4. Residual surface treatment. After the galleries have been treated and sealed, apply a residual insecticide to the entire surface of the affected wood. This layer deters new females from drilling in previously untreated areas and provides a chemical barrier that kills bees that land and attempt to bore. The product used for this is Suspend Polyzone, the same deltamethrin-based suspension concentrate covered in previous pest control applications on this channel. Its polymer formulation creates a microscopic film over the active ingredient after the spray dries, which protects it from rain and UV degradation. Outdoor residual effectiveness is up to 90 days per application. Mix at the higher end of the label rate, typically 1.5 fluid ounces per gallon of water, for maximum residual in a high-pressure Carpenter bee situation. Apply with a pump sprayer using a fan nozzle for even coverage. Coat the full surface of all wood at risk: eaves, fascia, soffits, deck boards, railings, posts, and any trim. Work at low pressure to avoid fine mist drift. The key advantage of Suspend Polyzone for this application is surface retention. Some liquid insecticides penetrate into wood as the water carrier soaks in, pulling the active ingredient below the surface where it can't contact a landing bee. The polymer technology keeps deltamethrin on the surface where bees encounter it. Bees may continue to fly around treated areas for a day or two after application. They can still hover and forage. The surface spray doesn't create an impenetrable airborne barrier, but females attempting to land and drill on treated surfaces will pick up the insecticide on contact. Reapply every 60 to 90 days throughout the active season, and again at the start of spring before overwintering adults emerge. The treatment protocol handles the active infestation. These steps are what prevent the next generation from establishing in the same locations. Paint all exposed wood. This is the single most consistently recommended prevention measure from University Extension Services and pest management professionals. Carpenter bees strongly prefer unpainted, weathered softwood. Painted surfaces are significantly harder to penetrate and less attractive by scent. 2 coats of exterior oil-based or high-quality latex paint is the standard. Stain and varnish provide some deterrence but less than full paint. Any wood that is currently bare and not part of the active infestation should be painted as part of the same season's treatment program. Replace vulnerable materials where practical. Pressure-treated lumber, composite decking, vinyl soffits, and fiber cement siding eliminate the softwood target entirely. For areas repeatedly damaged, replacing affected boards with composite or pressure-treated material during repair removes the most attractive nesting substrate permanently. Use Carpenter bee traps as a supplemental tool. These wooden box traps have entrance holes sized like Carpenter bee galleries, leading to a collection jar. Females investigating enter and can't find an exit. Mount them in spring in sunny locations near previously active areas. They won't resolve an established infestation alone, but provide ongoing population reduction that complements the main treatment. Monitor annually. Walk the structure each spring before Carpenter bee activity peaks, typically March to April in temperate climates, and look for any new holes that appeared over the winter or early spring. Early detection and treatment of new galleries prevents them from becoming multi-year nests. Annual inspection takes 15 minutes and prevents the compounding damage that makes Carpenter bee problems expensive. Carpenter bees are significant native pollinators. Among the few species capable of buzz pollination, a technique particularly effective for tomatoes, eggplants, and blueberries. The goal of this treatment program is protecting the structure, not eliminating the local population. If you want to minimize impact further, placing an untreated pine or cedar block in a sunny location away from the structure each spring gives scouting females an alternative nesting site. It won't solve a heavy infestation, but it's a practical coexistence measure that costs nothing. Carpenter bee damage is almost entirely a product of how long the problem goes unaddressed. Caught early, it stays cosmetic. Left alone across multiple seasons, it becomes a repair project. If you found this useful, subscribe for more practical, research-based pest control content. We'll see you in the next video.